Hi, this is Open Up Resources, High School Math, Algebra 1, Unit 2, Lesson 10, Point the Way. We are going to find patterns that are useful in writing equations for linear functions. So there are different ways of writing an equation for a line, and we're going to kind of identify what those parts are so that we know why we can write it different ways. So to start with, Grandma Billings is making a quilt and piecing together a number of blocks. Zach and Sion are watching and thinking about predicting the number of quilt blocks in this pattern. So this first one has 3. I like to always write what we've got going on. Second one has 3, 4, 5. Pattern 3 has 5, 6, 7. Pattern 4 has 3, 6, 9. Okay, so Zach said, I noticed that 2 blocks are being added each time. I thought it would be easier if I had the y-intercept, so I imagined what pattern 0 would look like by subtracting 2. That left 1 block at x equals 0, so I wrote the slope-intercept form. So I'm going to type that here. This is slope-intercept form. Slope is, we've got our slope right here, and then we've got our y-intercept, slope-intercept. So we basically said pattern 0, to take 2 would be 1. All right. Sion says, I also noticed that the pattern was growing by 2 each time. I saw that pattern 1 just has 3 blocks. Pattern 2 has 3 blocks plus 2 groups of 1 block on either side. Pattern 3 has 3 blocks plus 2 groups of 2 blocks. So I wrote b equals 2 to the times n minus 1 plus 3. So what does 2 times n minus 1 mean in Sion's equation? So we're going to put a few things here. 1, we know it is repeating the adding 2. That's what this first part is right here, that 2. And we also know it starts with the first term, which is that minus 1, right? So that's what we've used that for. So kind of just to kind of reiterate what Sion was saying. So for 1, pattern 1, 1 minus 1 equals 0. So we need 2 groups of 0. For 2, let me scoot this up a little. You can see it all. For 2, that's 2 minus 1, and that equals 1. So when I put in, basically what this is doing is I'm putting the 1 in for here. So 1 minus 1 equals 0. 2 minus 1 is 1. So we need 2 groups of 1. And if we were to go even one more time here, for 3, 3 minus 1 equals 2. So we need 2 groups of 2. So they're basically saying how many groups of 2 do we need as we're doing that. So are the equations that Zach and Sion wrote equivalent? How do you know? So let's just see. Can we solve one to reach the other? So I'm going to scoot over here a little bit and do it on this side. So we have, does 2n minus 1 plus 3 equal 2n plus 1? Well, if I take this and distribute my 2, I end up with 2n minus 2 plus 3. Does that equal 2n plus 1? And now I can combine a negative 2 plus 3. Negative 2 plus 3 is a positive 1. Does that equal 2n plus 1? Same. So yes, they are the same thing. So it's just a rearrangement of that equation. Let's go to the next page. So Marcus joined the conversation and noticed this. I was focusing on the strip of blocks in the middle and looking at patterns 3 and 4. I think you could also write b equals 2 times n minus 2 plus 5, and b equals 2 n minus 3 plus 7. Do you agree that these are equal to Zach's equations? Well, let's just go ahead and do that distribution again. 2n minus, let's do the first one, n minus 2 plus 5. So first I'm going to distribute that. 2n minus 4 plus 5. And now I can combine negative 4 plus 5. 2n, that is a 1. How about this one over here? 2n minus 2 plus 5. I distribute. Then I have 2n minus 4. Oh, wait. I just did that one. Minus 3 plus 7. There we go. So that's 2n minus 6 plus 7, which equals, when I combine a negative 6 plus 7, is 2n plus 1. So yes, these are. So Sion said, what is going on here? I'm going to look at a table so I can see if I can see why this is working. So he made this table and noticed this pattern. The equations they had written. So 1, 0 is 1. 1 is 1 plus 2. 2 is 1 plus 2 plus 2. 3 is 1 plus 3 plus 2 plus 2. 4 is 1 plus 2 plus 2. That's kind of the tables we were making before so that we could see if we needed to do an n minus 1 or an n minus 0 or whatever. And Zach said, so Sion says, I use this pattern I saw on the table to write another equation. This time it's 2n minus 4 plus 9. Zach says, I don't even need a table. I think 2 times n minus 5 plus 11 is another equivalent. So examine the table and compare it to the equations that have been written. Explain how Sion might have been using the table when he found this equation. So what he did, if they noticed that this was what was subtracted, and then 3 was what it was added. 2 was subtracted, 5 was added. 3 was subtracted, 7 was added. 4 was subtracted, 9 was added. So really all he did was he replaced the input and output value in each equation, right? Basically whatever our x was, whatever the x was, it went here, our pattern number. That was our pattern number. And then this one was our output, right? That's what we ended up with when we had a 4. Our starting point, our piece on there, what the fourth one was. Okay, so use Sion's method to find an equation for each of the tables below. So this is kind of like what we were talking about last unit when I said you can start with any x value and be able to do this. So I'm going to go ahead and do them with the text box. It's a little easier to see on here. So with this one, my y equals, well, what am I doing each time? Let's try to figure that out. So this one looks like a plus 5. Okay, so I'm repeating a plus 5, which means I need to have 5 and then the parentheses. That's what I'm doing over and over. But that's in my way. I'm starting with the 32nd term. So I'm going to do x minus 32 because that's my term number, just like it was up here. Let's see if I can do both. When I have that term number, I need whatever the output is as that I'm adding. So if I'm putting in a 32, then I need to add my first number here of a 50. So both of these end up going in my equation so that I can solve it out. All right, let's try it over here on this side. So for this one, it looks like I am subtracting 8. Subtracting 8. Okay, so let's figure out our equation. Y equals, so if I'm subtracting 8, I'm going to do a negative 8 over and over. I'm starting with 26th term, so I'm going to take away that. And then I'm going to add what that output is, and in that case, it's 78. So that's my equations for there. So let's try one more. And down here, let's see what we're doing. 32 to 39 is a plus 7. 39 to 46, that's also a plus 7. Notice I have a minus 15 here. So I'm going to do a couple things on this. First, I'm going to say y equals, it's a 7. I'm adding 7 each time, so I want that. And then I'm going to do x minus negative 15, right? Because I need to have, it's not a positive 15 this time, it's the negative 15 this time. And then I'm going to add 32 because that's a positive 32. Well, a better way to write this, what's a minus a negative? Plus positive. So y equals 7x plus 15, space in here, and then plus 32. So notice when I have a negative as my, the pattern number, basically, my term number, it's a plus on here. Just note that. All right, so what information do I need to write an equation using this method? Well, I had to have a point, right? Negative 15 comma 32. And then I had to have my slope. So I needed a slope, point and a slope. So using this information, I should be able to write the equation of this line right here. So let's see. My point is, I'm going to go ahead and type it over here. My point, I'm going to use, we use the 8 comma 3. 8 comma 3. Okay, so I have an x and y value. And then my slope is, let's solve for it. I need to subtract my y's over my x's. So 3 minus 1 over 8 minus 1 equals 2 over 7. So my slope is 2/7. So when I go to write my equation, y equals my slope, 2/7, and I have an x minus my 8, parentheses, and then I have a plus 3. So there I go. I put my point in here, and I have my slope. All right, so use this method to write the equation for the line with the slope of negative 3 and the point of negative 1, negative 5. So y equals, my slope is negative 3. I need that first. And then if it's a negative 1, x minus a negative is really plus a positive. And then I'm answer of negative 5 or plus negative 5. There we go. So Zach has a challenge. I bet you can't use the pattern to write the equation of the line through these points. Well, all we're missing is a slope, and we can find a slope through 2 points. So I'm going to go ahead and just do my slope over here. Slope equals, I'm going to subtract my y, so negative 5 minus a negative 3 over 3 minus 1. I always like to go left to right just because that makes it, I'm always consistent that way. Minus a negative is plus a positive. Negative 5 plus 3 is negative 2. 3 minus 1 is 2. So my slope equals a negative 1. All right, and it doesn't really matter which point I use. So if I just use the first point, y equals negative 1, parentheses, x minus 1 minus 3. Or I could use the other point and go y equals -1 x minus 3 minus 5. Doesn't really matter, right? Either one of those would work. Okay, so Sion is still thinking about this pattern and wondering if he could use this pattern to graph lines. Thinking of a starting point and using a slope. Try it with this equation. All right, I'm going to I'm going to select this, see if it lets me copy and paste, just so I have it to look at. Nope, it won't. Okay, so we'll just write it on the other side. So let me see that there. Okay, so I'm going to type it in up here. It was y equals -2, and it here, x plus 1, and then minus 3. Okay, so that was our, I believe, -2 x plus 1 minus 3. -2 x plus 1 minus 3. Okay, so looking at this, my starting point, there's my point, isn't it? And since it's a plus, that means it's -1, -3, right? And then my slope is the first number, -2. So then I can go over here to my table here. I'm going to my graph paper. I'm going to go ahead and just put some lines in here. Looks like it's going to go, if it's negative slope, we better have some space down. 1, 2, 3, 4. There's 5. 1, 2, 3, 4. -5. 6, 7, 8, 9. -10. 1, 2, 3, 4. 5, 6, 7, 8, 9. 1, 2, 3, 4. -5, 6, 7, 8. Okay, so first spot is -1, -3. -1, 2, 3. That's a first point. And if my slope is -2, then my next point is going to be right here on the 5. And I am going to go ahead and just do a line that kind of goes through. I'm going to eyeball this. I might actually put a couple more points in here, which means I can go up. I'm going up and down. Oh, not there. All right. So now I can do my line. Kind of goes through these points. Boom. All right. So there is my line of this. So what is it about lines that makes this work? What is special about a line? Well, a line has a slope that never changes. So it doesn't matter what point you start. Usually, we like to use the y-intercept. That's basically what you've learned up until this point, or until you got into algebra, was that it was slope intercept form. Once you had the y-intercept, you could write the slope from there. And so from here, it had been -2n minus 5. But you realize if we go up to left 1, then we are now at -1 comma -3. So it's all part of that. If we had tried this on a geometric sequence, it would not be the same because it's a different starting point. It still could work, but it's slightly different. So if you want to try the geometric, here's the ready for more. Grandma started to piece her quilt together again, and she's done this kind of growth, which if you are noticing, here's our geometric. 1 is 3, 4, 5, 6, 7. 2 is 2 of those, which is 14. 14, it's doubled again. So we've doubled it, which means y equals 2. Oh, wait. Our starting point, right? So if we start with pattern 1, it's 7 times 2 to the n minus 1, because that's our first pattern. But if we want to do the 14 one, then we have 14 times 2 to the n minus 2 this time. And if we want to do pattern 3, we would have to do 28 times 2 to the n minus 3, because we don't want to start that doubling until the fourth pattern. So that's one way you can show it with the geometrics. So it's not quite the same, but kind of. All right, point-slope formula comes from the slope formula. I'm going to prove that right down here. So let's go ahead and go back to this one. So our original is, let's start with our slope. Oh, it comes from the slope formula. So let's start with the slope. It's y minus y1, so the change in y over the change in x. Well, what we can do is we can multiply both sides by x minus x1. These cancel, and it leaves me with, I'm going to switch these around just so it's a little better format. Mx minus x1 equals y minus y1. And if I want to get this y by itself, right, because I want it to be in a y equals format, so I want that y by itself. To be able to do that, I have to add plus y1 to both sides. Well, I'm going to, again, rearrange this a little bit. Y equals, what do I have left on this side? Well, mx minus x1, and then I've added my y on the end. That is my formula that I have been using. I put in my point here, my x comma y, and I figure out my slope and I plug it in. This one is called, I don't really have a pink, do I? This is our slope point equation that we put in our slope point equation that we have put in our vocabulary. So, well, thanks for joining us. And we will see you next time.